Okay, so what I want to talk about today was PRVs, pressure regulating valves, also referred to as pressure reducing valves, uh, or by their acronym, PRVs. Um, Common stuff in irrigation. This one came off an irrigation system, but they find their uses in, industrial applications, residential, commercial plumbing. Like I said, irrigation, and their purposes is to regulate pressure. So some areas we have varying pressure, different altitudes, different water systems, different water purveyors, different pumps. We deal with a lot of different pressures. There are some, depending on where you're at, there may be some requirements set by the city or the local water department. But if you're at the bottom of a long hill, just from physics, you will end up with higher water pressure. And depending on how much that is, it can be destructive in a house or to an irrigation system. So the neat thing about PRVs is they can maintain an outlet pressure regardless, I want to say regardless, but at varying flows. If you had a ball valve and you cracked it shut and you had a constant flow, you could maintain a certain discharge pressure, downstream pressure. But if you had off and on and all these different things, you get basically the flow, the pressure might even equalize across it. We see that with leaking gate valves where, water shuts up, but over the course of a month, it basically equalizes when it has nowhere to go until the pressure, even with it being shut, equalizes across to the discharge side. So you might, maybe you've got a garage and you can see, the bonnet, or sometimes I almost refer to it as a bell sticking out of the wall. Sometimes you might open up your maybe an irrigation box in the ground and you see the top of one of these. Maybe you've got exposed piping and you can see the whole unit there. These units do have a limited lifespan. They are rebuildable. I'm not always a huge fan of PRVs. Sometimes they can bring about more problems, and there's other tools we can use in irrigation, with pressure regulated master valves. There are other steps we can take depending on what the pressure is and it's deemed, say, excessive. So the way a PRV works is we have a stem, we have a diaphragm, and we have another seat in the bottom. Water comes in. Its first step is going to move up to the diaphragm. It's going to push up, and it's going to try and block the flow of water to the discharge side. We have a spring on top, which in this picture you can see what's left of it. That spring lives inside the bonnet. So the spring is acting against the surface area of the incoming water, and it's trying to push that valve. It's trying to basically push that stem down and allow the water to pass through the valve. Now, if you turn, looking at my index here, if you turn the adjusting bolt down by loosen the lock nut, turn this in clockwise, the bolt basically extends downwards into the top of the bonnet, and it compresses that spring. The spring compressed will exert force. And so if you want to increase the pressure, you're going to basically push that valve open. If you turned it counterclockwise and you take that spring pressure off, less pressure pressing against the incoming water, the valve will want to stay shut. So in the case of this, when the spring rotted away with nothing else to, act against that water pressure, the valve failed shut, which is probably the best way it could fail. Because basically, A, it told us we had a problem, B, if it was really a sensitive application, there wasn't any other damage due to high pressure downstream. So this basically got pushed shut. If you look at the bottom, I've removed the other cap off this. You can see that's kind of that ring down there, and that's where the bottom of this, pointing my thumb, want to engage down. So let's look at a cutaway drawing. Now, it's not my drawing. It was originally a Watts drawing that I found online, and I found a colored one courtesy of, I think it was Inspectopedia. So, incoming water. Now this is a Watts. The one we have over here is a Wilkins 600 series. And generally I prefer Wilkins over Watts. But in the case of the Wilkins, incoming water comes up to the diaphragm, wants to push up. Water then has to flow down past the seat and out downstream side. When the spring goes away, water basically pushes against the diaphragm, pulls that stem, or I guess you may even call it a plunger, up against the lower seat. Water cannot move through that. So that's what happens. So like I said, how these things fail, In the case of the Wilkins, it failed shut. So the spring basically rotted away to the point it exhibited exerted no pressure against the diaphragm, and water couldn't flow basically freely. I wouldn't say freely, but it couldn't basically restrictive. It couldn't flow through it. So that's what I want to go over. That's how this failed. The other thing too is, if I remember right, you can also get a pressure regulator adapter for this. I'd always suggest installing a pressure regulator upstream and downstream of a PRV so you can monitor it. You know, to see if it's failing. If you want to make any changes, it's a lot easier to have those gauges right there, so you're not running back and forth and trying to do everything. Also, this is a single union, so there's an integral union that lives on this end with a O-ring similar to like a meter spud or meter tailpiece. So there's a flat gasket, and then you have basically almost like a straight cut thread that goes on there. So that's not MPT. Now on this side we do have NPT, be a 1-inch FIPT in here. So just want to go over that. Like I said, these units are rebuildable. You can find out more from Zurn by looking on YouTube. But that's all I got for today. Like, comment, subscribe. I don't claim to be any expert on this, just kind of my experience and having to diagnose and troubleshoot, pull these things out, always pulling stuff apart, see how it works, how it fails, so we can learn from it and do better next time. So that's all I got.